Assalamualaikum, my name is Muhammad Adib Afham. Today I will present about introduction and theory. For introduction, this experiment study the flow process in a two-stage reciprocating air compressor. The performance of a multi-stage air compressor is theoretically better than that of a single-stage compressor for the same pressure ratio and the same inlet air temperature. Air is inducted into the first stage of the air compressor through a bell-mounted inlet tank where the inlet air flow rate is measured. The first stage compressor will increase air pressure. Then the compressed air pass through the first heat exchanger to reduce its temperature before entering the second stage compressor. The second stage compressor will increase the air pressure further. After the second stage compressing, the air will flow through the second heat exchanger to reduce its temperature further before entering into the compressed air supply tank. That's about introduction. Okay, about theory for this experiment. Reciprocating compressor compress air by reducing a volume of air that has been trapped in a cylinder. In designing a reciprocating machine, it is necessary to analyze the process which occurs in a cylinder. A PV diagram is convenient for this purpose. In a single 18 air compressor, air is sucked in and compressed on one side of the piston. When the piston is at point 1, the cylinder is filled with air at pressure P1 and temperature T1. As the piston moves from point 1 to point 2, both the inlet and exit valve are closed, and therefore the trapped air is compressed. When the piston reaches point 2, the pressure inside the cylinder is significant to open the exit valve. As the piston moves from point 2 to point C, the compressed air is pushed out of the cylinder at constant pressure and constant temperature. The remaining volume in the cylinder is called the clearance volume, VC. The volume swept by the piston during its entire stroke from point 1 to point C is known as the stroke volume or swept volume, Vs. As the piston moves back from point C, the high pressure air that was trapped in the clearance volume expands to point D, where the pressure inside the cylinder falls to the inlet pressure point P1. At this condition, the inlet valve open and fresh air is sucked into the cylinder as the piston moves further from point D to point 1, completing the circle. That's all about theory. Thank you.
Assalamualaikum. My name is Muhammad Faizan bin Ahmad and my matrix number CD180085, and I will present about procedure about this experiment. On the water valve, make sure the flow rate of cooling water is 100 L/H. Adjust it using the valve, then connect the water inlet and outlet to the valve number 1 properly. Connect the cable into the bergraph D1 for compressing air at pressure 4 at 2.5 bar. Switch on the start at the air compressor. After complete the setup, wait about 10 minutes to get a steady state condition. During the 10 minutes, make sure the pressure 4 always at 2.5 bar absolute by controlling the bergraph D1. After 10 minutes, record the value of temperature and pressure, temperature 0, pressure 0, temperature 1, and pressure 1. After 5 minutes, record the value of temperature 2, temperature 3, and pressure 2. After 5 minutes, take the value of final compression, temperature 4, and pressure 3 with the same step as before. After that, record the data and repeat step unit for pressure 4 at 4 bar and pressure 4 at 7 bar absolute by changing the cable flexible into the bergraph D2 and D3. So after that, I will present about observation. Firstly, make sure that the flow rate of cooling water is sufficient, approximately 100 L over H. Throughout the experiment, the flow rate varies in a small range, but approximately 100 L over H. Before air compressor is turned on, check valve to be closed. The air compressor work so the experiment can be directly conducted. After pressure fall is kept at a constant value such as 2.5 bar, the ambient air temperature and pressure is recorded. Then waiting in 10 minutes to get a steady state condition. That's all about this experiment. Thank you.
Assalamualaikum, my name is Muhammad Noor Idris bin Juhairi. Today I will present about the result of two stages of air compressor. In this slide, there are two tables which are at table 1 is about of reading first stage compression, second stage compression, while at table 2 is about reading of air flow rate, input power and so on. Okay, for the result, I will explain about the journey of air from atmosphere until storage tank. Okay, we look pressure at 2.5. Okay, firstly, the air from atmosphere entering the compressor, the first stage compressor with T0 at 35.3 degrees Celsius. Okay, then the air will be compressed and the temperature of air will increase to 132.4 degrees Celsius, which is T1. Then the air will be through the heat exchanger 1 to decrease the temperature. And then at the second stage of air compressor, the temperature is decreased to 43.6 degrees Celsius, which is T2. Then at the second stage of air compressor, the air will be compressed again and the reading of temperature is increased to 96.1 degrees Celsius, which is the reading of T3. And then the air will through the heat exchanger 2 to reduce the temperature, and finally the air will entering the storage tank with the lower temperature. Thank you. Okay, next I will present about the discussion. Okay, the discussion is about, is air compressor considered as a closed system or open system? Okay, the compressor is considered as an open system because there is no addition or reduction on it. An open system is a state of system in which a system continuously interacts with its environment. The basic characteristic of an open system are environment, input, throughput and output, and same control system with feedback.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ar-Rashid bin Norzali, and I will be continuing on from the previous slide on the conclusion. From the experiment, the conclusion that we can get is the objective of the experiment to understanding the polytrophic process in the two-stage air compressor is achieved. Also, we can conclude that the polytrophic efficiency of the compressor can be calculated from the result table. There, we can get all the data from the lecture given. The last one is students can expose themselves to the application and realize experience of the air compressor operation. So that's all from us. Thank you.